amid the intense atmosphere of the Milano Cortina 2026 Winter Olympics. Where victory is sometimes decided by just a few centimeters on the ice, very few people realize that behind every match are curling stones worth more than $600 each. A complete set of Olympic curling stones consists of 16 stones and costs nearly $9,600. To produce them, manufacturers must quarry massive granite blocks weighing several tons from a remote island off the coast of Scotland. However, more than 90% of the raw material is discarded during the selection process. On average, 1 ton of granite produces only about 6 stones that meet international competition standards. So what makes these curling stones so expensive? Today, join Mandarin Tech as we explore the entire manufacturing process behind Olympic-grade curling stones. In curling, the stone is the centerpiece of the entire game. Every delivery, every collision, and every strategic decision revolves around a block of granite sliding across the ice at a speed of only a few meters per second. Unlike many other sports, where performance depends almost entirely on the athletes, curling places extraordinary importance on the quality of the competition stone itself. For this reason, the World Curling Federation enforces extremely strict standards for this equipment. To meet international competition requirements, a curling stone must possess exceptional durability, uniform weight, the ability to withstand repeated impacts, and most importantly, the capacity to produce a consistent and predictable trajectory on the ice. These demanding requirements have turned curling stone manufacturing into a highly specialized craft that has existed for more than 170 years. Today, only around 10 master craftsmen remain dedicated to preserving and practicing this unique tradition. Every Olympic curling stone begins its journey at the same location, Ailsa Craig, an island situated about 16 kilometers off the coast of Scotland. The island is the remnant core of an ancient volcano that became extinct tens of millions of years ago. As the molten rock cooled slowly beneath the Earth's surface, it formed unique granite deposits with the properties required to meet the demanding standards of curling. 2 different types of granite are quarried on the island. The first is common green granite, which is used to manufacture the main body of the stone. The second is blue-hone granite, a much rarer material found only in certain areas of the island. This granite is later used for the running surface on the bottom of the stone that comes into contact with the ice. Quarrying operations are not carried out continuously. Instead, they take place in periodic campaigns separated by several years. Because there are no permanent quarrying facilities on the island, all drilling equipment, stone-cutting machinery, fuel supplies, and lifting equipment must be transported from mainland Scotland by sea. Once a granite deposit of suitable quality has been identified, quarry crews drill guide holes into the rock surface and then use mechanical cutting methods to separate large granite blocks from the bedrock. This approach minimizes internal cracking within the material, a critical requirement for the precision manufacturing processes that follow. After extraction, the granite blocks are marked and sorted according to their granite type before being moved to a loading area. There, specialized cranes and forklifts lift the blocks onto transport vessels for shipment back to mainland Scotland, where the next stages of production begin. Once the granite blocks arrive on the mainland, they are still far from becoming curling stones. At this stage, they are merely candidates for production. Master craftsmen begin by cutting the multi-ton granite blocks into large slabs using industrial diamond saws. Every cut is carefully planned to maximize the use of the material while minimizing internal stresses that could affect the stone's long-term performance. The slabs are then moved to an inspection area where craftsmen search for even the smallest imperfections hidden within the granite. A hairline crack, a microscopic void formed as the magma cooled millions of years ago, or a zone of uneven mineral composition buried deep inside the stone is enough to disqualify the material. What makes this stage remarkable is that it still relies heavily on human expertise. Machines can measure dimensions, cut stone, and perform precision machining. However, they cannot fully replace the judgment of craftsmen who have spent decades working with Ailsa Craig granite. Using visual inspection, reflected light on the stone surface, and knowledge gained from evaluating thousands of granite blocks, these specialists determine which sections are suitable for further processing. This is one of the main reasons why curling stone manufacturing continues to be regarded as a unique and highly specialized craft. Inside the workshop, these cylindrical granite pieces have a unique nickname: cheese. Before being shaped into their final form, they resemble giant wheels of cheese waiting to be processed. This stage also highlights just how demanding Olympic curling stone production truly is. A finished stone weighs only about 20 kilograms. In theory, a single ton of granite could produce dozens of stones. In reality, the numbers are far lower. After all the inspection, selection, and core drilling stages, 1 ton of granite typically yields only around 6 cores that are suitable for continued production. One core may be rejected because it is located too close to an area of uneven mineral composition. Another may be discarded after microscopic cracks become visible following the cutting process. Even granite that appears perfectly normal can be rejected if it fails to meet dimensional requirements or does not come from the optimal section of the slab. For that reason, this stage is far more than a simple shaping process. It serves as the final screening phase for the raw material itself. By the time the drill has completed its work, only the finest cheese blanks remain ready for the next step of manufacturing. Many people assume that an Olympic curling stone is carved from a single block of granite. In reality, it is a composite structure made from 2 different types of granite. After the granite cores have been approved, craftsmen begin combining the 2 materials into a single stone. The main body is made from common green granite, which accounts for most of the stone's mass and provides the durability needed to withstand countless collisions during competition. However, the most critical component is located on the bottom. Technicians machine a circular recess into the base of the stone and fit it with a separate insert made from blue-hone granite, a much rarer material cut from specially selected blocks. This process requires a high degree of precision to ensure that the 2 types of granite form a perfectly integrated structure. The use of 2 different granites is not intended to save material. It is an engineering solution. Common green granite provides strength, toughness, and impact resistance for the main body of the stone. Blue-hone granite, on the other hand, has a denser structure, absorbs very little water, and maintains exceptional stability in prolonged, low-temperature conditions. These characteristics make it the ideal material for the portion of the stone that comes into direct contact with the ice. Once the assembly process is complete, the stone still looks relatively rough. Sharp edges, flat surfaces, and the original cylindrical shape are far from Olympic standards. At this stage, the stone is mounted on a lathe, where the initial shaping process begins. Layer by layer, excess granite is removed, gradually transforming the heavy cylinder into the distinctive rounded profile of a curling stone. After the initial shaping process is completed, the stone moves to the precision machining stage, where it is transformed from a handcrafted product into a piece of competition equipment that meets international standards. The World Curling Federation establishes strict technical specifications for competition stones. From height and diameter to weight, every detail must remain within approved tolerances. At the Olympic level, even the smallest variation can influence how a stone travels across the ice. To meet these requirements, each stone is mounted on a precision lathe. Material is gradually removed according to carefully calculated specifications. While machines perform most of the cutting work, the process is not entirely automated. Technicians continuously measure the actual dimensions and make adjustments when necessary to ensure that every stone within a set possesses nearly identical characteristics. Weight is also monitored with great precision. If one stone is significantly heavier or lighter than the others, its momentum and response during collisions can differ. That would mean the match is no longer being played under perfectly equal conditions. Although the stone has been machined with high precision, its most important feature is neither the body nor the handle. It is a narrow circular ring on the bottom known as the running band. Many people assume that the entire base of a curling stone touches the ice. In reality, only this small ring makes contact with the playing surface. The stone's movement, speed, and trajectory all depend on this area. To create the running band, technicians use specialized grinding machines to shape the bottom of the stone to exact specifications. Both the profile and surface texture must be carefully controlled. If the surface is too smooth or too rough, the stone's behavior on the ice can change. This stage is critical because the running band creates the sport's signature curling motion. As the stone rotates, the band interacts with the tiny ice pebbles on the sheet, producing the curved path seen during competition. Even the smallest variation can affect speed, rotation, and stopping position. That is why the running band, despite being only a small part of the stone, is often considered its most important component. After the running band has been completed, most of the critical machining stages are finished. However, the stone is still not ready for competition. Technicians continue by polishing the entire body of the stone to remove any remaining machining marks from the surface. A uniform finish makes quality inspection easier and helps reduce minor damage that could develop during years of use. The next step is the installation of the handle, the most recognizable component of a curling stone. Handles are typically manufactured from high-strength composite materials and are painted red or yellow to distinguish the two teams during a match. Each handle is precisely mounted at the center of the stone using a specialized bolt system. But the handles used in modern Olympic competition contain far more than just bolts and paint. In recent years, international competition stones have been equipped with an electronic system known as Eye on the Hog. Inside the handle is a sensor capable of detecting the exact moment a player releases the stone. In curling, players must let go of the stone before crossing a designated line on the ice called the hog line. If this rule is violated, the delivery is considered invalid. In the past, determining such violations relied entirely on the judgment of officials. Today, the sensor built into the handle performs this task automatically. If it detects that a player is still touching the handle after the permitted release point, the system immediately activates a warning light, alerting both the referees and the spectators. Before leaving the factory, every curling stone must pass a final inspection. This stage confirms that all previous manufacturing processes have met the required standards and that the stone will perform consistently in international competition. Each stone is inspected individually. Technicians verify its dimensions, weight, and the uniformity of the running band. The goal is not to identify the best stone, but to ensure that every stone within a set performs as similarly as possible. In the curling stone industry, this stage has long been associated with a respected figure named John Brown. For many years, he was responsible for inspecting and approving the final stones before they were delivered to major tournaments. His approval represented one final layer of quality assurance from a craftsman with decades of experience. If any deviation is detected, the stone is returned for adjustment or additional machining. Only after meeting all technical and quality requirements does it receive competition certification. At that point, the journey from raw granite to Olympic equipment is nearly complete. What began as a block of volcanic granite on a remote Scottish island has passed through quarrying, selection, core drilling, assembly, precision machining, and rigorous inspection. The finished stone is finally ready to reach the ice, yet its story is only beginning. Unlike many other pieces of sports equipment, a properly maintained curling stone can remain in service for decades, continuing to glide across the ice long after the day it was first certified for competition. From the stands, a curling stone appears to be nothing more than a block of granite quietly gliding across the ice. Yet behind it lies a journey that begins on a remote volcanic island off the coast of Scotland, passes through a series of precision manufacturing stages, and relies on the skills of craftsmen who have spent decades mastering their trade. What makes these stones truly remarkable is that they are built to last far beyond a single tournament. Many Olympic-grade curling stones remain in use for decades, taking part in countless matches and sometimes becoming part of the sport's history. Perhaps that is what makes a curling stone so unique. It is not simply a piece of sporting equipment. It is the result of geology, engineering, and traditional craftsmanship coming together in a single object. Thank you for watching. Don't forget to subscribe to Mandarin Tech for more fascinating engineering stories and manufacturing processes from around the world.